If you'd recall, last week we were all about learning our values, knowing our values. And what we mean by that is we want to take our sine, cosine, and tangent out of the acute angles, out of the right triangle, and spread it all the way around the Cartesian plane. And to do that, we built a unit circle so that we could learn sine, cosine, and tangent of all the angles on the quadrants, 0, 90, 180, 270, and 360, and everything that has a reference angle of 30, 45, or 60 degrees in all four quadrants. So 30, 45, 0, 30, 45, 60, 90, 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, 330, and 360. Sine and cosine going all the way around. It's all combinations of, it's all going to be plus or minus 0, a half, root 2 over 2, root 3 over 2, 1. That's the order that it goes. Goes up and then down and then up again. We also started drawing sine waves to help us learn our values and to preview stretching out our trig functions over the real number line. So we can start applying them to sine waves that we encounter out in the line. But on top of that, you've got all this other homework problems, that are less about just learning our values and more about using the stuff that we learned about. Let's take today and look at some of the homework problems that we got stuck on. But before we do that, let's remind ourselves of what we can do. Because if we have a list of the things that we learned how to do in this class, then it's harder to get stuck on a problem. Because we'll just take one of the things that we know how to do and see if that fits the situation that we happen to be in. So before we begin, what is it that we know how to do? Find angle measures. Yeah, that's a great one. And find side lengths. And what are all these things in? And oh, what was that? And the hypotenuse. So find side lengths, find angles, and what are all those things contained in when you start it? And a triangle. That's one of the things we know how to do. We know how to solve triangles. Remember, last week was all about moving those acute triangles all around the unit circle. But what do we know how to do? Solve triangles. Solve right triangles. Given a right triangle, I'll give you two pieces, and you can tell me all the rest of it. Given a right angle plus 2, you get, that's 3 things. Tell me the other 3 things. So given right angle, not 20 others, it's not that many parts. That's the solving right triangles game. Given a 90-degree angle plus 2 other parts, I can ask you to find the other 3 parts. Solving the triangle would be find all other 3 parts, but any individual problem might just be given a 27-degree angle and the hypotenuse, find the side opposite. That was like that windshield problem. You were told that the vertical on the windshield was 4 feet, and you were told in a roundabout way what the angle was. It's kind of a roundabout way, but because instead of just saying the angle is 60 degrees, they said the tangent of this angle is square root of 3. From there, we figured out that it was 60 degrees. But then we had the 90-degree angle and 2 parts. We could find any other parts. That's one of the games that we definitely know how to play. If we're looking at a problem, even if it has some weird diagram of the bones of a foot, Look for that problem. Somewhere in there, there's some kind of triangle. Any questions before we jump over and do some problems? How's everybody okay? Everybody looks stunned. Sometimes it looks mad, but I don't know if that's just because it's a math class. And we all have preconceived notions about how people feel when they're in a math class. Angry. Stunned and angry. Are you stunned because you're angry or angry because you're stunned? A little bit of both. All right, that's fair. That's fair. Let's take a look at a problem. So we had homework from this chapter 2. That's the homework that that was due on Sunday, but we could still be working on it. And there was a question from 2.2, and it was problem number the 5th. This was the foot problem. Oh, dang, I wanted that. That's it. So there's all kinds of stuff. So this problem is subject to what I refer to as the 4-line rule. If a problem takes more than 4 lines to state, we'll just skip it and ask the teacher about it tomorrow. And this one clearly you could see takes 5 lines, 2, 3, 4, 5. None of these 5 lines are really all that important, because if we scroll down, we see this, we say, oh, hang on. Now everything before it said secant of theta equals 4 centimeters over 3.9 centimeters really is just blah, blah, blah. Because now I've been given 2 parts of a triangle with a 90-degree angle. I can find out some other stuff. And one of those things is probably the answer that we're looking for. And furthermore, since we're doing the problem on a computer with an unlimited number of guesses, we'll be able to, once we calculate it, we'll be able to find out. So mine always tell me the answer. This is, I don't have to know how to do anything. I get the answers in mine. So all this stuff is just like, we don't need to know, because we see the thing that should make us do something. We see that the secant of theta is 4.0 centimeters over 3.9 centimeters. So this is 2.2 question 5. So there's all kinds of stuff being said, very interesting, about bunions. The audience for this class is a little pre-bunion, but that's okay. It's just set up. And then we get to the actual math part of the problem. We see this statement, secant of theta is 4.0 over 3.9. We have just been given 2 parts of a right triangle. So we can figure out what the other parts are. So let's see what we're given. First of all, we're given secant of theta. What is secant related to? Secant is the cosine. Secant is the reciprocal of cosine. So if secant of theta is 4 over 3.9, what is the cosine of theta? Not just 1 over 4. The 4.0 will go down here, but what happens to 3.9? Secant of theta and cosine of theta are reciprocals. We just flip them over. Secant is 1 over cosine. 1 over something just is the reciprocal. Flip it over. So now we can see we've got 2 parts of a triangle, and that is a problem that we know how to deal with. 3.9 and 4.0, what are those in terms of the sides of a triangle? Cosine is what over what? Adjacent over hypotenuse. So 3.9 is the adjacent. 4.0 is the hypotenuse. So I can imagine a triangle. Theta. Adjacent is 3.9 and hypotenuse is 4.0. Oh, and these are centimeters. Have a look at it. Right now, the only triangles we know how to solve are right triangles, but that's what all the information was giving us. We're given all this information. Let's just interpret that in the problem that we know how to do, which is solve right triangle. So I've got two sides. We got to figure out what we're trying to solve for. What can we solve for? What's something that we can solve for right away? We can find the other side. What would we use to find the other side? Pythagorean theorem. Yeah, we've got two sides. We want the third. We can find the third side. Right now, I haven't looked over and see if that's the question. But one thing we can find is the third side. So let's use Pythagorean theorem. So we get 3.9 squared plus the opposite squared is going to be 4.0 squared. We're just taking two of the pieces we know, and we're going to find the third one. So whatever the opposite squared is, I'm going to take the 4.0 squared, subtract the 3.9 squared, and then take the square root. So the opposite side will be the square root of 4.0 squared minus 3.9 squared. And I'm just going to write it in calculator C. I wonder if I brought my calculator. Square root of 4.0 squared minus 3.9 squared. Close the radical. Now, if we go back to the problem, we should look up what we're even asked to find. Let's go back to our problem. Find the distance between the distal ends of the two metatarsals. Wow, words, words, words. We had two sides. There's a third side. That's probably the one that we're looking for. You don't have to worry about what the distance is between the distal ends of the metatarsals, because we saw the problem that we know how to solve. Given two sides of a right triangle, we found the third side. That's all we know how to do right now. So if we try to plug in, I have it on teacher view. So our answer says 9 millimeters, and we're looking at that and we say, no, we got 0.889. This is 0.889 centimeters. So to convert that to millimeters, we need to move it over one place. So that's why we're going to rewrite our 0.889 centimeters as 8.89 millimeters. And then that rounds to 9 millimeters. We're going to do that because the instructions were to round the nearest millimeter. And we're going to do that because there are 10 millimeters in 1 centimeter. In this case, that was the thing that we wanted in the problem. We didn't really have to know what we were talking about as far as like the names of the bones or distal end versus, I can't even remember what the other end is. We don't have to remember what those terms represent. We have to remember we're in a trig class. We know how to solve right triangles. Triangle has 3 sides. We've been given 2 sides. We're probably looking for the 3rd side. That's the only thing that will come out in the end. How's everybody okay? What else could we do with this triangle? I've got the 3 sides now. What else could we do? We could find the angle. We're given that cosine of theta is 3.9 over 4.0. We're given that the cosine of theta is 3.9 over 4.0. So how can we find the angle theta? What will we do here? We'll use an inverse cosine of 3.9 over 4.0. If we want to find an angle, we use an inverse trig function. So let's grab our calculating machine, do an inverse cosine of 3.9 over 4.0. 12.8 degrees. That wasn't necessary in this particular problem. That's just another thing that we could do. So in the case of the problem, although this was not a question that came up, it says the angle theta formed between the metatarsal of the big toe and the metatarsal of the second toe is called the first intermetatarsal angle and is normally less than 9 degrees. In the presence of a bunion, the intermetatarsal angle exceeds 9 degrees. So that's certainly what it looks like in this case. We measured these metatarsal bones, and we were able to calculate an angle of 12.8 degrees. So this would indicate the presence of a bunion. How's everybody okay? That wasn't part of the problem, but we just needed to solve a right triangle. Is there anything else that we could find in this triangle? There's another angle. How can we find that other angle? Yeah, the 2 acute angles of a right triangle will be complementary. So if I just subtract 12.8 from the 90, I can find the other angle. It doesn't have a name, so I'll just call it other angle. Is there anything else? No, that's it. Triangle has 6 things, 3 angles and 3 sides. We were given 90-degree angle, 4.0 hypotenuse, 3.9 adjacent. We found the opposite at 8.89, the angle 12.8, and the other angle 17.2. We didn't come up with a name for the other angle. That's just like, they're going to be they didn't have a speaking role, so they're an extra. we did have a speaking role, we'd have to give them a credit, and that credit would say other angle. Video game terms, other angles in NPC is a problem. Not like a quest giving NPC, it's just like a background NPC. So we're like doing all these problems, and then this other angle walks by. So do you get cloud districts very often? No, what am I saying? Any questions on this problem? Remember what you can do. Right now, what can you do? You can solve right triangles. So the problem is probably asking you to solve a right triangle. Look for what two pieces of the right triangle you're given after the right angle. And then go from there. Triangle right there. Subtract from 180. Inverse trig functions. Any other questions on homework problems? Number 3 and 3 and 6. Let's take a look at 3 and 6. Three is going to be most like this one, so we'll do 3 and then we'll do 6. So in problem number, is this the problem number 3? The volleyball problem? Angelina spikes a volleyball such that the angle theta is the angle of depression for the path of the ball. The ball makes with the ground, and secant of theta is 10/9. And all of a sudden, everything else to me looks like blah, blah, blah. I see secant of theta equals 10/9. And I know that one of the only things I could do at this point in my trigonometric career is to solve a right triangle. So that's what I'm going to do. So it's like volleyball. That sounds exciting and fun until we start doing math. Then it's like, then we get to the math part. Secant, oh, it's even secant of theta again. That's convenient for us. Secant of theta is 10/9. The only other thing that I would want to worry about with this one. Oh, we have another piece of information. The ball is hit from a height of 8.9 feet. How far does the ball travel? See, last time I didn't write down what the question was. How far does the ball travel along the path of the ball before hitting the ground? All right. So in this case, let's make sure that we get the correct right triangle. We're told that theta is the angle of depression to the ground. So the angle of elevation and the angle of depression are always measured from the horizontal. So for an angle of depression, just like an angle of elevation, always measure that from the horizontal. What we know how to do at this point in our trig careers is to solve right triangles. So it looks like this is the right triangle that we are solving. We're given some information about the angle theta, and we're told that the ball was hit from a height of 8.9 feet. So this looks like the height of 8.9 feet. And the question was, how long is the path from the ball to the ground? So it looks like we're asking about what is the hypotenuse. So it says, what's the length of the path from the ball to the ground along the path of the ball? Now we might think maybe the ball is going to be like all curvy or anything like that, but then we're going to remember that we're in a trig class, and in trig class, in the first month, we solve triangles. It's a straight line. So it's not going so fast that air resistance is going to be a problem or like have a curve or anything like that. It's going to go nice and straight line because that's the technology that we have in week 4 of trig class. So it looks like this is a piece of information that's going to give us something about the angle. We've got this height of 8.9 and we want to know about the hypotenuse. What's something that we can figure out? We've got secant of theta is equal to 10 over 9. You can do what? Yeah, we can use the 10 and the 9 as side lengths in a triangle. But it's unlikely that this is going to be the hypotenuse because maybe this height is different. If secant of theta is 10 over 9, what's that in one of our more common trig functions? Yeah, we can use similar triangles. So we could say cosine of theta is just like in the last one, reciprocal 9 over 10. So we can have this as the adjacent and 10 is the hypotenuse. So we have an adjacent of 10 and a hypotenuse, adjacent of 9 and a hypotenuse of 10 in a similar triangle. Because this 8.9 is opposite the theta. So this triangle we're talking about has an adjacent of 9 and a hypotenuse of 10. What can we do to find this side here? Pythagorean theorem. We could do the same thing we had before. Now, we're going to be making similar triangles. I don't know if they're the same. Let's calculate the side and find out. I don't know why this triangle had to be orange. I think it's because I wrote cosine up here in orange. So the opposite side is going to be the square roots of hypotenuse squared minus adjacent squared. So 4.36, we'll call it. So we have the triangle where we get the angle information. If we set an adjacent of 9 and a hypotenuse of 10, that would give us an opposite of 4.36. We want to take the 4.36 and scale it up to an opposite of 8.9 using similar triangles. So we want to turn 4.36 into an 8.9. And whatever operations will do that, we'll turn our 10 into the hypotenuse that we want. I should have known that I was not going to fit in this spot right here. You had like a professional teacher, like this kind of thing wouldn't happen because they would plan ahead, but y'all are stuck with me, so. See? Told you. So we're going to look at the ratio 4.36 over 10. Actually, I'm going to do 10 over, I'm going to smear it. So I'm going to make a ratio of 10 over 4.36, and that will be equal to our hypotenuse that we're looking for over 8.9. I smeared, every time I smear the ink, I think of, all I can think of is Dalgo. So in this case, we can use similar triangles to find out the hypotenuse that we were looking for. So I'm just going to take the 10 over 4.36 and multiply both sides by 8.9. So 20.41. 20 point. Here's the good news. This is not the only way we could have solved this problem. Here's the bad news. This is not the only way we could have solved this problem. So it's like, oh, good, there's more ways than one to do this. Oh, crap, there's more ways than one to do this, because then we have to decide. It's much easier if there's only ever one way to do a thing. But there are many ways to do a thing, which is why you could never explain to someone how to do something on their computer. And so they'll be like, oh, you just right click here. And then if you're watching them explain it, you're like, what are you talking about with this right click? You don't want to right click, you just want to drag and click. You know, there's always more than one way to do something, right? So you can never explain it to anybody. So let's look at the category of other things we might have done. That piece of information we're given, secant of theta is 10 over 9, which we translated into the much more rational cosine of theta is 9 over 10. We could use that to find the angle theta. If cosine of theta is 9 over 10, we could use this to find the angle, find out what the angle is. Cosine inverse of 9 over 10. And so that's an angle of 25.8 degrees. So in the triangle that we drew, lots of blank. In the triangle that we drew, we could use that piece of information to figure out what the angle is. So rather than doing a similar triangles technique, we just figure out what that angle is, 25.8 degrees. See, 25.8, the 8.9 is opposite 25.8, and the hypotenuse is what we're looking for. What trig function involves opposite and hypotenuse? Sine. So 8.9 opposite. Hypotenuse is what's in question. We could say the sine of 25.8 is opposite over hypotenuse. So we figure out what the sine is, multiply by hypotenuse, divide by sine of 25.8, and the hypotenuse is 8.9 divided by sine of 25.8. Oh, I don't even have to round it off. Have it as an answer. So the first way we went about the problem was to use the suggestion of similar triangles. Similar triangles means I don't care about no angle. I don't need to know about the angle. I'm still asking about the sides from these similar triangles. In the second one, we're thinking, I know how to find angles in a triangle. Why don't I use this information to find the angle and then use that angle to find the side that I need. All of them were based on the one thing that we know how to do, which is solve a right triangle. How's everybody okay? Yes. Yeah, and the other way, I looked at the secant of theta is 10 over 9. I translated it into the more rational cosine of theta is 9 over 10. So that means 9 can be the adjacent and 10 can be the hypotenuse. And that means the Pythagorean theorem to find the 4.2. I did. I just rewrote this. This would have started off with opposite square. So this was opposite. I just did the same thing as I did before, which started off as opposite squared plus 9 squared is equal to 10 squared. And then we solve that for opposites. That would have been the same as this step up here, where I wrote the Pythagorean theorem and then wrote it to solve for the opposite. How's everybody okay? Yes. The coterminal? Coterminal just means angles that end at the same spot. So if we have an angle in standard position, no, it can be, it's just starting, the initial side is on the positive x-axis. So in standard position, your initial side is always here. So if we have, let's say, 120-degree angle, it's measured from the initial side and positive is counterclockwise. So that's why 120 degrees shows up over here. No, this is the terminal side. But 120 degrees is not the only way to get to that terminal side. Going clockwise, that's one way to get to the terminal side. But we could go around the other direction. No, the terminal side is just the other side of the angle. Coterminal would be how we measure the angle. So this angle here is going in the negative direction. So this is negative 240 degrees. So what we would, the way we would use this, the coterminal is we'd say 120 and negative 240 are coterminal. Cool. Let's take a quick break, come back and do some more homework problems.